Hello everyone. In this video we will cover higher order derivatives. So far we studied just finding the first derivative. Now we will be solving questions about finding second or third derivative. So first of all we should know how the second, third or the other derivatives, notation of these derivatives. First derivative we use y prime or f prime or dy over dx. Second derivative it's y double prime, f double prime or d squared y over dx squared. Third derivative y triple prime, f triple prime and so on. After fourth derivative we don't use primes anymore. We use numbers inside brackets. So if it's fourth derivative, it's like y to the inner bracket fourth power. So there's a difference between the power and the degree of derivative. If there is power, it's y to the fourth. If there is degree of derivative, y to the fourth inside the bracket, there is a difference. Be careful. This is about exponents. This is not. This just indicates fourth derivative. So after 4, you write the numbers. If it is sixth derivative, you write 6 in the bracket, seventh derivative, write 7 in the bracket, and so on. Okay, let's start solving questions. First question, test prep 13. Find second derivative, y double prime. So first, find first derivative. There is product here, apply product rule, derivative of first, 1 times second function, sine x plus first function times derivative of second function. And this is my first derivative. I need y double prime, which indicates second derivative. So derivative of sine, cosine, plus derivative of this product, derivative of first function, 1 multiplied by second function, cosine x plus first function x times derivative of second function negative sine x. If there is any simplification, we will simplify. Cosine plus cosine 2 cosine x, and negative comes in front, negative x sine x. Okay, that's my second derivative. All right, another question. Find the second derivative of this function. There's a division here. It's an exercise and ministry question. And for these kind of questions, the first thing that comes to your mind might be using quotient rule. But using quotient rule twice, since we are finding second derivative, is tiring. If we simplify the function, rewrite the function and take derivative, it's much more easier than using quotient rule. Let me show you how. Here we have 3 terms at the top divided by x at the bottom. And it means that x is common denominator for all of the numbers at the top. So it's the denominator of x squared. It is denominator of 2x. It's also denominator of minus 1. Okay, we can separate this fraction, write it as a sum of 3 different fractions. So when you simplify, we have x plus 2 minus x to the minus 1. So when I do this, I'll do a little bit less work. So taking derivative is much more easier than taking derivative of the quotient. Now, let's start taking derivative. First derivative. Derivative of x1 to 0 and minus x to the minus 1 is minus minus plus x to the minus 2. Derivative of second derivative of the function is, here we have 0, here power down in front, decrease the power by 1, so you can rewrite this as negative 2 to the power 2 divided by x cubed. Alright, see, this is pretty simple when you simplify first. Okay, another question, it's an exercise question and it came in with Ari also. In this exercise question, it is 1 over cosine x. In that ministry question, it was 1 over sine x. Now, take first derivative. First derivative is easy. Derivative of top, 0, times bottom, 0, minus top times derivative of bottom. Derivative of bottom is minus sine x. Minus minus becomes plus. So we have sine x at the top, at the bottom, cosine squared x. So derivative of division is derivative of top times bottom minus top times derivative of bottom over bottom squared. This is my first derivative, pretty easy. Second derivative, It's also easy, but simplification part is a little bit tiring. So derivative of top, which is cosine x, multiplied by bottom, minus top sine x times derivative of bottom. There's power, apply power rule first. 2 cosine x multiplied by derivative of the base minus sine x over cosine to the power of what? It was 2. When you square it, it becomes 4. Now let's try to simplify. Cosine, cosine, cosine squared. No, it's cosine squared, right? So cosine, cosine squared, cosine cubed x minus minus becomes plus sine squared x times 2 cosine x all over cosine to the fourth. Now, I'm done with taking derivative. The rest is simplification. I don't think I will see this in options. I should simplify this more. I can, I think, rewrite sine squared as 1 minus cosine squared, right? Remember a trigonometric identity saying sine squared plus cosine squared equals 1. So sine squared is 1 minus cosine squared from that trigonometric identity. So it becomes cosine cubed x plus, let's distribute 1 minus cosine squared to 2 cosine x. So 1 times 2 cosine x, 2 cosine x, negative cosine squared times 2 cosine, negative 2 cosine cubed. Still, it's not simplified. Now I can see cosine cubed minus 2 cosine cubed, which makes minus cosine cubed. And I also see a common factor, which is cosine at the top. Cosine is common. So take cosine out, cosine x out. Inside we have negative cosine squared plus 2, just 2, over cosine to the power of 4x. So 1 cosine, cosine from the top, and 1 cosine from the bottom will go. Result becomes negative cosine squared x plus 2 over cosine cubed x. If it is in the options, you are lucky. If it is not, let's say your answer is the top is written in terms of sine, then by using the same trigonometric identity we used here, you can turn cosine squared into 1 minus sine squared, so your top will be written in terms of sine. So your last answer always depends on the options. This is the answer, this is also answer, this is also every step is the answer actually, but we don't know what appears in the options. So according to the option, we will manipulate the answer by using identities. Okay. Let's continue with another exercise question, which is much more easier than the previous one, simpler. We are asked to find sixth derivative when fourth derivative is given. So we are lucky we are not asked to find sixth derivative when f of x is given. We are already given fourth derivative. Now we are going to find fifth first. Take derivative of 2x plus 1, which is 2. Now sixth derivative of 2, 0. That's it. Okay. There is a rule saying that if f is an nth degree polynomial function, then f of n plus 1 x is equal to 0, which means if the degree of the derivative is 1 more than degree of the function, then derivative is 0. No need to solve. No need to solve questions from starting the first and second and third and fourth and so on. Whenever the degree of the derivative is more than degree of the function, then the derivative is 0. So here, the next question is related to this note. Which of the following is true for that function? A mystery question. What is the degree of this function? 2 here, 1 here, 3, 4, 5. So it is fifth degree polynomial. We don't need to expand it. It takes time. It is not necessary. We just need to identify the degree. This is fifth degree. So after 5, according to this note, after 5, then sixth degree derivative is 0. 7th degree derivative is 0. 8th degree derivative is 0. So after 5, derivatives will be all 0. So not third, not fourth, not fifth, sixth. 6th degree derivative will be 0. All right. Okay, let's solve some mystery questions. F of x is given. F triple prime of x is asked. Third degree derivative is asked. Okay, let's try. All right, f prime of x. I can write 1 over x as x to the minus 1, by the way. So the first derivative will be x to the minus 1, negative in front, negative x to the minus 2. Derivative of cosine minus derivative of the angle 2 sine 2x. This is first. Second, we are lucky that we don't have product, otherwise it would take years. Second derivative, negative comes down in front, negative 2, so it makes positive 2x to the power of, reduce the power by 1, 3, minus derivative of the angle 2 times 2, 4, times cosine of the same angle. I am still not done. I need one more derivative, f triple prime. Negative 3 will come down in front, so it makes negative 6, x to the power of, reduce the power by 1. Okay, derivative of cosine is sine, derivative of the angle is 2, 2 times negative 4, negative 8. Derivative of cosine negative sine, it makes positive sine 2x, so that's what we are looking for. Negative 6 over x to the fourth, because when you get rid of that negative exponent, it's negative 6 over x to the fourth. Negative 6 over x to the fourth plus, not minus, sine 2x. So that's my answer. So it is not as difficult as it seems. Since we don't have product, it doesn't take that much time. Another mystery question, find the second derivative. All right, we have two ways of solving this. Find first derivative. Derivative of sine squared is, apply the power rule to down in front, sine x times derivative of sine cosine x. To find second derivative, you can either apply power rule or just use the identity. There's a trigonometric identity saying that whenever there is 2 sine x cosine x, it's equivalent to sine 2x. So I can use sine 2x instead. Instead of taking derivative of the product, I can take derivative of sine 2x. It's much more simpler. Okay, derivative of sine 2x, 2 cosine 2x, which is option C. See, when you know the identities, it makes your job easier. All right, last question about higher degree derivatives. An exercise question, and it came in Vezari. Which of the following is true? Okay, f g double prime minus f double prime g is equal to this. So in order to identify which one is true, we should solve the right parts. So we should solve the parentheses. See if it's equivalent to the left side. So when you solve this, there is a derivative here, prime. So take derivative of everything inside. Here I have product. Here I also have product. So apply product rule for both. Now for the first couple, derivative of f, derivative of this product is derivative of first, which is f prime, times second, g. It was g prime, it becomes g double prime, plus first f times derivative of second. Sorry, what did I do? Derivative of first times second. It was supposed to be g prime only. I didn't take derivative of second. I took derivative of first, second time, plus first times derivative of second. Now it's g double prime, minus derivative of first, f double prime, times second. It was plus because there's minus in front. When you distribute it, it becomes minus. First times derivative of second, G prime. Now, is there any simplification? F prime G prime, F prime G prime will cancel each other. So we will be left with F G double prime minus F double prime G. Is that same? F G double prime minus F double prime G. Yes, it is exactly the same. So that's true. A is true. B. Now open this parenthesis. We are asked to find second derivative of this product. Okay. First derivative. Derivative of first times second plus first times derivative of second. Now we are going to take derivative of this one by one. Derivative of f prime, f double prime times g plus first f prime times derivative of second g prime plus first f times first derivative of first times second plus first f times derivative of second. Now in simplification, f double prime g, f prime g prime, f prime g prime, there are two f prime g primes. So it's going to be f double prime g plus 2f prime g prime plus f g double prime, which is not the same as the left side. So that's false. A is true, B is false. Again, this ministry question, we have, of course, 4 options. So you are supposed to solve every option like that. You solve the right part, see if it's equal to the left part.